All right, here is the answer key for the practice quiz. Read in the book about the limit laws and translate it into simple English. It is as you would expect it or hope it to be. The limit of two things being multiplied is simply the product of the limits. The product meaning you multiply each of the separate limits. Okay. Then in the second one here, you've got this function, f of x, with all these nice gnarly bits happening. And then we're asking what's going on right here. It says as x gets closer and closer and closer to negative m, but from the right. So what's happening to the x values as it gets closer and closer and closer to negative m from the right? That is exploding to infinity. All right. We'll talk about this more in detail later, but that is the way we will state that now. Here, B, x is getting closer and closer and closer to n from the left-hand side, positive n from the left-hand side. So like this, as x gets closer and closer to n, it looks like this value here is approaching a. And now it's saying as x gets closer and closer and closer to m, this is not saying which side, from the right or from the left. So if you look at this picture, if you don't know if it's from the right or from the left, you don't know if it's going up or going down. So this is the famous does not exist. All right. Here we go. Here's the limit as x gets closer and closer to n. And again, there's no specification from the right or from the left, but in this case they agree from the left and from the right that they're getting closer and closer to positive a here. So that's okay. And then finally just evaluate f of n. That's going to be b. All right. It does say if the limit does not exist, explain why. And here you can just say the lim as x approaches m from the left of f of x is not equal to the limit as x approaches m from the right-hand side. The two sides must agree, all right, like they do in Part D. All right, on to the fun math you've been looking forward to. Here we have evaluate the limit if it exists. Well, try plugging in negative 5 right off the bat. You want to do that. Well, when I plug in negative 5 and square it, I get positive 25, and that gives me 0. So I'm going to go right to the factoring. So that's the limit as x approaches negative 5 now of x plus 5 times x minus 5. If you need to practice your factoring, practice that all you want. Factor out, whoops, look at that. I'm talking too fast. That's just simply times x. All right. I've just factored out an x from above, and that's plus, because that's plus. Now this one is x plus 5 times x minus 5. All right? So these cancel then, and you wind up with the limit as x is over x minus 5. Now when I plug in minus 5, I get, according to the direct substitution method, minus 5 over minus 10, which equals 1/2. All right? This one, I sub in 3, I get 3 minus 3 gives me 0, so this is one of those square root ones. So I'm going to multiply top and bottom by the conjugate, which is x plus 1, and then this is plus 2, and x plus 1 and plus 2. These are going to be equal, because it's just the number 1. When I do my foiling, I get the same pattern. The middle bits always cancel when I do the rainbow part. So I end up with the first thing squared. It's the limit as x approaches 3. The first thing squared is x plus 1, and then minus 2 times plus 2 is minus 4, and then that's all over x minus 3. Well, lo and behold, when I do the math here, this becomes minus 3, and these cancel perfectly to give me 1 all the time. So no matter what, the limit here is 1. When I come to this next one here, and I do the substitution, I plug that in, I get 0. You might recall that it's exactly the same as the one up above. There I get x over x minus 5. Now when I substitute 5 in right there, I still get 0. 5 over 0 means does not exist. All right. And finally, I've got one of those fraction ones. I'm just going to rewrite this as the limit as x approaches 0. And this is 1 over 4 plus x, because that's what the minus 1 means. It's the same as just the inverse or the reciprocal. 1 over 4. And that's all being divided by x. Okay, well, I'm just going to save myself a step here. Instead of dividing by x, I'm going to multiply by the reciprocal, 1 over x. Okay, if you're not comfortable with fractions to that degree, practice a few. Notice that if I have like 7 over 5 divided by 3, that's the same thing as 7 over 5 times 1/3. All right? When I do the math here and get the common denominator and I multiply and multiply there, I'm going to have then the limit as x approaches 0, and it's going to be 4 in the numerator minus 4 plus x. When I multiply this up above to 1, I get 4 plus x, but the whole thing is being subtracted. And then in the denominator, I get 4 times 4 plus x. All right. Well, when I do the substitution, when I distribute the minus sign across there, I get minus 4 and minus x. This whole thing, do not forget, is times 1 over x. Well, these 4's cancel, okay? And then I wind up with the limit as x approaches 0 of x over 4 times 4 plus x times 1 over x. Well, these x's then cancel, and it's just 1 over 4 times 4 plus x. Well, now I can substitute in 0, and it's 1 over 4 times 4, which equals 1 over 16. Okay, there we have it. Good luck.